Hi guys, welcome to first day of Precalculus online. We are actually starting a new chapter, so and hopefully it'll be pretty intuitive. But yeah, we'll see how this goes. So I want to set up some expectations since this is a new way of learning. There will be video almost every day, I think, about 10 to 15 minutes long, and it will be uploaded on YouTube, and the link will be shared on Google Classroom. So make sure you check Google Classroom and use school email. So obviously watch the video and to understand the concept, and I will go through a couple examples. So if I went through so fast or something didn't make sense, rewatch the video as you need to. And then make sure you communicate, especially earlier on, because I have no idea how much assignment you will be getting from other classes and how heavy your workload would be this week. And so, yeah, make sure you communicate with me through email and comments, and I will be available for answering questions and stuff like that between 10 to 4 p.m. And if you don't know my email address, it's right here. When you do homework, unless it's like an online homework, make sure you do it on a piece of paper. Take a picture, upload the homework on Google Classroom. There will be a submission if you need a paper homework. And make sure you show all your work, since yeah, that's one way for me to see if you understood the concept. Okay, so let's start with a new chapter. We're on chapter 10, sequence and series. And before we start the chapter, there's some vocabulary we need to go over. I don't remember if we did anything in Algebra 2, but I will just assume that this is all new to you. And so, if you have a textbook, you can go to page 590, and that's where I'm starting. Okay, so sequence is a list of numbers. That's all it is. It's a list of numbers, and it can be any pattern. Okay, finite sequence, as you can see from the word finite, it's a limited number of I guess, terms. Okay, so then what is a term? If I have an example of a sequence like 1, 2, 3, 4, 5, each number is a term. So we call this one first term because it's the first number in this sequence. And this one will be the fifth term, which would be the last term in this finite sequence. How is an infinite sequence different? Well, all you need is ... because it goes infinitely. So that's the two types of sequence that we've seen, and there are more types. There is depends on the pattern of the numbers. You can have an arithmetic sequence and geometric sequence, which we will look into in section 2 and 3. But let's talk about some formulas. Obviously, we love formula because they give us terms that we need right away, and that's the kind of formula that you're looking for, an explicit formula. It's like an equation, almost like a function, right? So if you plug in n into a formula, you will get to know what the nth term of that sequence would be. So we'll look at some example. Recursive formula is a formula that you build off from the previous term. So for example, the explicit formula for this one is n. Okay, let me write it as, so a is usually the term, so it's a nth term. That means if I plug in 1, I get 1, right? My first term is 1, that's what it says. Recursive formula, however, is a little different because it has to build off from a previous term. So n minus 1, that would be the previous term. And if you add 1, then you will get the term that you're interested in, which means you always have to provide the first term or else you can't really use a recursive formula. So in this case, if I want to know the third term, you actually have to know the second term, and then you add 1. Since we don't know the second term, let's try to figure out by using the recursive form. And we know A1 is 1. So then A2 is 1 plus 1, which is 2. So then A3 will be 3. Okay. Fibonacci sequence is another special type of sequence, which you will explore more in Mathagon, which is the website that I want you to use for this section. So I'm not going to go into that. You will explore that online. Converge and diverge. Converge is basically when you have a sequence, so basically think of it as there is a limit for converge, and diverge is that there is no limit. Limit does not exist. Okay, so diverge will something like go on forever, like infinity. Okay, whereas converge has a limit. It has a limit to a unique integer, or I guess it doesn't have to be an integer, unique number. Series is sum of, it's basically sum of certain terms in the sequence, okay? Again, finite series means that you are adding up a finite number of things in your sequence. Infinite series is that you add up until it goes forever, basically. So you will use a limit to find out infinite series. And that's when we will determine whether it converges or diverges. Nth partial term is written as S of n, S meaning the sum, okay? And think of it as a finite series, okay? Partial sum. Sigma notation is another thing that is quite important for us to explore, and we're gonna learn how to read those notation in a bit. Okay, so sigma, big sigma. All right, so let's look at this example. I want you to stop and solve this, and then you can restart the video and find out the answer. Okay, hopefully you stopped. So first thing, we have to kind of recognize a pattern here, right? 5 and 10, it increased by 5. But then here it increased by 10. And then it increased by 20. So it almost looks like if you multiply 2 to the previous term, you will get the next 2 terms. So then the 2 terms that you're looking for is 80 and 160. The second one, I'm adding 1 and I'm adding 4. I feel like it may not be with addition. So let's explore multiplication. First, I multiply by 2, and then I multiply by 3, and then I multiply by 4, and I multiply by 5. So this looks like a reliable pattern that we have. So then the next number, I'll multiply by 6, and I'll get 720. And then the next number, I'll multiply by 7, and I'll get 5040. Last one. This one is added by 2, and then 4, and then 6, and then 8. So it looks like there is a pattern that you just add 2 more. So basically you're adding even number. So I'm going to add 10, and I'm going to add 12 to find the next 2 terms. You'll be like, okay, Ms. Kong, like how do I know these patterns? Well, you have to explore. It might take some time if it's not as, some of them are not as intuitive, right? So like, for example, number 2, I first look at it as an addition because that's a lot easier for me. But then I realized that it increased very quickly. So that means I should probably look into multiplication because multiplication tends to increase more than addition. All right. So then we're going to use number 1. From the example before to find out explicit formula. Remember, explicit formula is like a function, okay? So think of it as a function of n. When n is, I guess like number, like the nth number. So this is n of 1, n of 2, and 3, and 4. Okay, so we write it as a of n, which is the nth term of this sequence. All right. Well, what I've noticed was that it was times 2, right? There was a relationship of times 2. So I know 2 will be involved. Again, this is another thing that you have to kind of play with. And so don't be surprised if I come up with something that you take like 30 minutes, because I actually looked at it for a good while to figure out and then tweak my functions to have a formula that would work consistently, right? So I know there's something to do with 5 as well, right? But then I need to use the variable n, and my n started with 1. So let's say if I have n on top of 2 as a power, then I get the second number, not the first number, right? Because 2 to the 1 power times 5 will be 10, and that's not my first term. What do I need to do? Well, I guess I can just subtract 1. So then if I plug in 1, I get 2 to the 0 power times 5, and 2 to the 0 power is 1, so it's 5. All right, so I feel like I came up with a function. Okay, and then I will check another number like 1, 2, 3, 4. Let me check n equal 4. So then 4 minus 1 is 8, because 2 cubed times 5 is 40, which I should get. So that means my formula is probably accurate for this sequence. Again, don't worry if you can't come up with it in 2 minutes, because it will take some time. Recursive formula, there are 2 elements that you need to have. First, you need to define a1, so 5, that's easy. And then we need to use an minus 1, because that's the previous term, to describe the next term. And what was the relationship? Well, this one is a little bit easier because it's times 2. Basically, if you multiply 2 to the previous term, you'll get the next term. So all these elements is part of the recursive formula. Okay? All right, quickly, let's move to notation. You should be able to tell which one is explicit formula and which is recursive formula. This one is explicit because you can just plug it in what n is, and you will get the number that you want. This one, because of the presence of the a1, we know this is a recursive formula. If I ask you to find fourth term, which I can write it as a4, this one you plug in 4 where n is. This one, unfortunately, you will have to find a2, a3, then you can find a4. So you can see when we prefer explicit formula versus recursive formula. Last one, sigma notation. Couple things you need to know. This is the first term, k equal 1. Okay, so that means you start by plugging in 1, the very first term. 5 is where you stop. So this one, if I rewrite it, it looks like 200 minus 1 squared plus, because this is a summation, 200 minus 2 squared plus all the way to 200 minus 5 squared. And it doesn't have to all start with 1. For this case, it starts with 2 and it goes all the way to 8. Okay? So if you understand that sigma notation and know how to read it, basically it's plugging in, you'll be fine for now. And we'll explore more into arithmetic and geometric sequence tomorrow. And I want you to go to Mathagon website. I posted the link on Google Classroom, and hopefully you'll be already invited, because I invited y'all to be on that. And you will do the sequence and series, and there are a couple modules, and so it's not due till Tuesday, but I urge you to start now, and so that you don't have to rush through things. I think it'll be interesting, and it's a little bit more interactive than me just talking at you. So I hope you enjoy, and I hope you explore other concepts if you're interested and if you have time. I will see you tomorrow.